Git stores your project of code in repositories. Repositories can reside in two places, locally on your computer and on a remote server. You can make changes to your project locally, and then you will push these updates to the remote server so that other team members can then pull those updates. This is all terminology that you will learn in the next few tutorials. Many companies host their own remote server code repositories, but as students, we will take advantage of a free hosting service known as GitHub, which will act as our free remote server. GitHub is a very common online resource, and the free version allows all Git features except for private repositories. First, we need to register an account on GitHub. This is possible by following the steps online at github.com. Please pause this tutorial and complete the registration before continuing. Now let's create a repository for our team project right now. Go to github.com. Click on New Repository. Enter in the repository name. Name it after the name of your team's project, keeping in mind that the name must be web safe, so spaces and other characters will be escaped. Give your project a brief description. This will be used to automatically create a project README file. If you click that option, Git ignore files act like exemption index files. These can be very useful. On GitHub, there are several options depending on the coding language that you will be coding in. I suggest that you pick your project type here and allow Git to create that code-specific Git ignore file for you. Later on, we will learn about editing our Git ignore files and how to get the most out of them, so don't worry about making a permanent, irreversible decision here. Click on Create Repository. Your repository is now hosted online at GitHub. Now, open up SourceTree on your machine. You will notice that the program seems blank because you have no repositories open to work on. It is time to get a local copy of the repository from GitHub so that you can make changes to it. First, we will need the remote address of your GitHub repository. Go to github.com. Click on your newly created repository. Notice on the bottom left the link to your remote repository. Copy this address. We will now clone this repository to your local machine. Return to SourceTree. Click on File, Clone/New. Paste in the remote address to your GitHub repository in the source path/URL box. In the destination box, pick a local directory that you want to store this project in. Make the decision now where you want this repository to reside all semester. I do my development all in a directory I created at C/development, but you may do whatever fits your preference. Make sure that Bookmark this repository is checked. Click on Clone. SourceTree will then download all the files you have created online to your local machine, which should only be two at this point, the Git ignore and the README. What we have just done is called cloning a repository. Cloning is used when you and your teammates want to work on the same project together. Another process you will hear of is called forking a project, which is similar to cloning a project, except that the project will be first cloned to your personal account before you can then clone it. We will not be forking in these tutorials, but I did want you to hear the term as you will come across it on online threads and information databases. Now you have a repository initialized on a remote server and have cloned that repository to your computer. Typically, a single repository holds a single project, and it is possible that in your careers you will be downloading several repositories and making changes to them separately. Last, I want to show you what is happening to the directory you chose to be your local destination. Go to that directory on your computer. Once you deem that directory to be your local repository container, Git is always checking to see if any changes are made to that directory. Changes include adding files, editing files, or removing files. Renaming files, according to Git, is classified as removing a file and then adding a new file with a different name. If any changes are made anywhere inside of the project directory, even many subfolders deep, then Git/SourceTree will notify you of those changes and allow you to either discard or save, called committing, those changes. This will be covered in the next tutorial. The last term to understand of this tutorial is the term hash. Hashes are unique, identifiers of some data that have gone through an algorithm. Hashes are much smaller than the original data, resulting in anywhere from a few to several character long strings. The way that Git knows if you have changed a directory is by using hashes. Right now, your directory and everything inside of it, the 2 files at this point, have been hashed, producing a hash code. The hashing algorithm that Git uses is the SHA-1 hashing algorithm. If you make a change to that directory, then the hash will be different from what it was at the latest saving point, known as a commit. Git becomes aware that something has changed from the difference of the hash, and allows you to decide what to do with that change. Every commit in Git has an associated hash, which we may use as we search the repository in later tutorials.